Welcome.
Hi, I'm Vincent. I currently finished my bachelor studies in economics.
Hello, I'm Ervis. I'm currently working as a senior data scientist in Bridgestone Mobility Solutions. And together with Vincent, we have built the team Northlichter.
And we participated on the challenge 1 and how to increase active mobility. But without further ado, we proudly present our presentation we came up with in this Citython. So, hi. Wait. Share sound and let's go.
My name is Vincent, and I invite you to hop in and follow along as we show you our vision for the future of cycling in the city of Hamburg. Cycling is an important cornerstone for sustainable mobility. In fact, studies show that cycling in the city can reduce the CO2 emissions of one person by 300 kilograms per year.
To tackle this issue and to increase active mobility in the city of Hamburg, we first looked on the possible reasons people do not favor to cycle in the city. We came up with 5 main risks cyclists are facing at the moment and potentially prevent them from opting for active mobility. These are high CO2 pollutions, hazard events made by motorized vehicles, bad road conditions such as potholes and gradient, and potentially icy roads. Based on these challenges, we implemented a solution that addresses all these issues, which my colleague Ervis is presenting in the following.
Imagine you have to make a trip to a certain destination and you have 2 or 3 available routes to follow. The obvious choice is to select based on the minimum distance. But what about whether you have information about the level of the CO2 emissions for every trip, potentially icy roads part, potholes detected, hazardous events, or road smoothness or road gradient? Bike routine optimization model is developed exactly for that case. Its main goal is to assist bike users make the right choice based on advanced external data and select the most appropriate trip for their route. This for sure will make you evaluate all of this information and select the most appropriate trip according to your needs. To begin with, City of Hamburg would have to work closely with mobility companies or car manufacturers and take advantage of leveraging real-time granular data to improve decision-making. Integrated the data from these external companies in the urban data platform of the City of Hamburg. The data are continuously feeding the endpoint of cities API through streaming and batches processes, giving to the city the ability to host a huge treasury of data which might be used for several use cases. A data flow lifecycle is continuously running every 30 minutes where the data from different sources are transformed, cleaned, and integrated into a unified single dataset. A developed bike routine optimization mechanism delivers to a navigation platform dynamically generated KPIs that reflect the service level agreement between the City of Hamburg and the navigation system. The solution we propose is cost-effective and feasible so that without much time and without a lot of money, city might provide these valuable informations to their citizens and in that case to increase active mobility in the city and provide the right incentives in order they can use their bicycles rather than their motorized vehicles.
So take a look for yourself how our bike route optimization model can be used in a daily life situation. Last but not least, I would like to introduce you to the brains and people behind our model. Ervis, Andreas, and myself.
Yep. On that point, I would like to spend the last 30 seconds of our presentation to focus on the feasibility and the cost effectiveness of our solution. We expect about 40 million vehicle probe data per day, which it's approximately 40 euros per day for the city. It will cost about 40 euros per day. Also, the storage in, let's say, in an Azure storage will, for about 200 gigabytes, will cost approximately 25 euros. Regarding the feasibility part, we have the expertise and the know-how to lead and implement this solution if might needed. And of course, the data will be used for various use cases in order to transform the urban infrastructure of the city of Hamburg.
Thank you.
Yeah, thank you very much.
Thank you for this inspirational video. I mean, if I don't need to be here, I will take a bike and go to the beach right now. But I will give the opportunity to our jury members to ask questions and or to clarify their doubts in reference to your solution now.
Can I ask the first question? Thank you very much. Thank you very much for the impressive video and the idea. It is undoubtedly a very good idea. I would like you to further develop 3 points. One is if the route changes, so the optimal route of the parameters that you are proposing changes during the trip. What does it? Is it foreseen that it's dynamic? Let's say because bike trips sometimes are very long in cities, so can be very long. Is it foreseen? Yes or no? This would be the first question. My second question would be concerning the financial aspects of this app. Have you thought about who is going to pay for what? If not, it's fine, but I would like, if possible, that you further develop this point. And the third one would be the scalability of this software, because I understand that this is done for Hamburg. How is the complexity of doing this for let's say Munich or even, I don't know, Krakow in Poland? Thank you very much.
Thank you very much. So yeah, I will start, clarify all of this question. So basically, regarding the first question, the answer is no. Right time in that time we have thought about, the driver is taking his application and wants to search 3 routes. So basically, it will take the route that let's say will have the smallest level of CO2 emissions and the less level of hazardous events by motorized vehicle as measured, before 30 minutes or so. But of course, this can be aligned in future plans, but it will need further, investments. Regarding your second questions about the financials, yeah, we have thought about it. So, like I said previously, regarding probe data, we consider about receiving telematics and signals from fleets that are moving vehicles in the city of Hamburg. So we expect about 5,000 moving vehicles traveling around in the city of Hamburg, which will produce 10 seconds level data so for every 10 seconds we'll have a probe data point for every vehicle. This will lead to about 40 million data points per day. Approximately, this will cost for every 1 million, the cost is something like €1 for every 1 million data points, which lead about 40 euros per day, something like 600 euros per month. The Azure cost now, the storage, it's very low. So for 200 gigabytes of storage, which I think is sufficient, because at the end we will not, there is not a bike route in every road. So we will have to gather data for specific roads where we have, both a road line and and also a bicycle route at the same time. So it might be less than that cost. On the other side, the less part of the cost is, from the navigation system, which the city might need to, make a specific service level agreement with, let's say, TomTom or Google Maps. I'm not very sure to answer that part, but for sure, I think that I truly believe that by having, this collaboration and these companies earn money by providing the data, this is very nice part to make a nice agreement by the city with the navigation system in order to take a piece of that pipe, of that cake. So also imagine that the city will receive trips data from the navigation system in order to evaluate and make these KPIs for the routes. So that means that you can transform the urban infrastructure, because if you see that specific trips are made in specific bike road, then you can change this you can change the other bike roads and add another line which decrease the traffic congestion and therefore we decrease the CO2 emissions. Can you please repeat the last question?
The last question was about the scalability of the project. Yeah. Maybe I can also hop in on that. Yeah. So basically, we know that that Hamburg has the urban data platform, and it's nice to have it because we can integrate our data there. But basically, what we can say is that these companies, the fleet companies, are basically available in every major city, and that's why we also see the scalability, and we could see Hamburg as a prototype how it works. And then also use that as an idea for other cities.
Yeah.
Okay, thank you. I'm sorry I could not find the button to unmute myself and I could not answer for the third question. It was indeed Scalability. Very clear. Thank you very much. You went directly to the point. Thank you.
Have we time for one more question, or is time out already?
I think we have, yeah. I don't...
Sorry. One question. Do you already think about to have a cooperation or an interface for a very famous application like Komoot? It's a bike navigation system, Komoot, so it's quite popular in Germany, and of course it's quite an easy way to integrate it, and then you can participate to the business model as well.
Definitely correct, and thanks for that comment. I know Komoot, but to be honest, at that stage we didn't think about like a specific bike navigation system. But definitely a big chance. But also I see, because I think a lot of people also use the standard applications like Google Maps, so it would be really a major point, and I think a major factor to implement it in a navigation system which is really widely used. I know that Komoot, like cyclists like who are really into it, use it, but on a daily basis to get the normal customer, it's really important to implement it on a platform which is like used by really a lot of citizens.
Okay, thanks.
Yeah.
Hello.
Hello.
Thanks for your nice presentation. I think you have thought a lot about the technical solution, but I want to make another question, which is this app could be very nice for bike users, but the goal is that car users go to bikes. So for me, it's difficult. Maybe car users should have an app saying you are, your CO2 is very high. I don't know, but I don't see that this app can convince car users to switch to bike. So I don't know if you have thought about.
Yeah, for sure we have thought about it, and our intention is to provide the right incentives, to the car user to start using their mobiles more frequently, their bikes more frequently. Because personally, for me, I'm both a car user and a bicycle user. If I know, for example, that in a particular route there are not very cars, so they are not producing a lot of CO2 emission, where are you when you are cycling? It's not very healthy. It's dangerous for your health, to having all of these vehicles producing CO2 and you cycling in that road on that part. So if I know, for example, the gradient of the road, so I will not have to harsh a lot, to drive my vehicle, and let's say they are not making a lot of hazardous events, then it might be a good, indicator for me in a particular day. Of course, I cannot do it every day. We know that this is for a specific segment of citizens. It's not for all, but I truly believe that it will give me the right incentives to take my bicycle and make a healthier life, and not just take my bike for 5 kilometers going in the park by taking my car, let's say.
And making one point clear again, we have what we also said in our presentation, we would like to have the data used in the front-end application back in our database to analyze it as a city. And that's like a major point, because as a city, you can see, okay, why did this route have been chosen by some cyclists more often than another one? And having this information is really nice, because you can think about what are the reasons,